Okay, dear students, today's class we will discuss what is drift velocity and what is the expression for drift velocity and relation between drift velocity and current. Okay, so what is drift velocity first? See here. First I want to discuss what is drift velocity. Okay, na? Let us consider it is your conductor. Okay, na? Inside the conductor what happens? There is a lot of electrons are there. Okay, there is a lot of electrons. So drift velocity means what? It is the average velocity with which the free electrons are drift from the metal wire when the potential difference is applied. Okay, now see here. So whenever I am going to apply this potential difference V, then what happens? Average velocity means these electrons are starts to move with certain velocity. Okay, na? Certain velocity. So from this definition we can conclude that the drift velocity is equal to average velocity of the electrons. Okay, na? So what I had told, the drift velocity means the average velocity of the electrons with which the electrons are moving in the metallic wire when the potential difference is applied. Whenever I am applying a potential difference, then what happens? Motion of the electron is takes place. So how the motion of the electron is takes place? Opposite to the electric field. Okay. So suppose the current is moving along this direction, the electric field will be along this direction. Both are in opposite direction. So from this V, drift velocity is equal to V at average velocity. Okay, na? V at average velocity. So V at average velocity means what? V average is equal to, if there are n number of electrons. Okay, if there are n number of electrons, this drift velocity is equal to V average can be written as V1 plus V2 plus V3 plus V4 up to Vn divided by if there are n number of electrons is. Okay, see here. Then this V drift velocity is equal to V1. It can be written as initial velocity u plus a times of tau 1 I am taking, where tau is called relaxation time. Okay, what is relaxation time? See here, it is your first electron, it will be your second electron. Okay, when this electron is going to collide with this electron with a time, that time is called your relaxation time, or else the successive collision between two electrons, the time taken is called your relaxation time. Okay, na? Or else the average time, or else the successive collision is there, na? So to make one collision it may take a certain time. That time is called your relaxation time. Then u2 plus a times of tau 2 up to un plus a times of tau n if there are n number of electrons. So this V drift velocity is equal to u1, shall I write, plus u2 plus u3 plus a is a common, take it outside, a times of tau 1 plus tau 2 plus tau 3 up to tau times of n. Here is also u times of n. Is or not? So this V drift velocity is equal to u1. So whenever before applying this voltage, then what happens? U average must be 0. Okay, na? Initial velocity must be 0. See, initial velocity must be 0 means before applying of this battery, okay, na? That electrons are moving with thermal velocity. We don't know in which direction they are moving. Okay, is that not? So if all the electrons are moving in the same direction, then only we can conclude that the current is flowing. Okay, so same direction, we don't know in which direction the electrons will move. That's why we are taking whole divided by n. This u becomes our 0. I am writing u1 plus u2 plus u3 up to un divided by n plus a times of tau 1 plus tau 2 up to tau n whole divided by n. This whole term becomes 0 because of randomness of electrons. V drift is equal to this whole terms is 0. Okay na? Plus a times of tau. This whole tau is taken as only 1 divided by n. Okay na? So then this V drift velocity is equal to a times of tau divided by n. Okay. So electric current in conductor. Previous video I had told that what is acceleration. In which acceleration the electrons will move. It will be this V drift is equal to minus E divided by m tau times of n. So let us take this n is equal to 1. Okay, n is equal to 1. Then this V drift is equal to minus E divided by m times of tau is the final expression for drift velocity. Okay, na? Minus E divided by m into tau is the final expression for drift velocity. Okay, na? Next, see what is the relation between drift velocity and current. Okay, na? What is the relation between drift velocity and current? So I am rubbing this. See the next relation between drift velocity and current. Relation between drift velocity and current. Okay na? See, let us consider a cylinder. Okay na? It will be our cylinder. Length of the cylinder is taken as L. Okay, I am taking a cross sectional area over here. It has electron, lot of electrons were there. This is a point A, it will be your point B. Across the end of conductor I am applying potential difference Vd. Okay, potential difference Vd. Then see here, whenever the potential difference is applied, then what happens? This charges, means these electrons are starts to move from point A to point B. Okay na? From point A to point B. Then what happens there? If these electrons are moving from point A to point B, it may take a certain time. Is or not? It take a certain time. That small time is taken as dt. Okay. So there are n number of charges. Okay. This area of this cylinder is taken as A, and charge of the electron is E. Okay. So see, just I am writing this dq is equal to charge on electron, means number of charges into charge of electron. Charge of electron I am writing. Okay, so this dq is equal to number of charges must be n. Okay, then these electrons are moves with a drift velocity Vd. Okay, then while moving from point A to point B, it takes a time dt. Okay na? Then if E is the charge of electron, then area of this cylinder is taken as A. Okay, then this dq is equal dq divided by, I am taking it as dt. Okay, now dq divided by dt is equal to n vd e a. Okay, what is dq by dt? it is your instantaneous current, or else we are taking as current itself. Okay, this is I is equal to N times of VDEA, where N is called number of electrons, VD is called drift velocity, and E is called charge of electron, and A is called area of, or else cross sectional area of the cylinder. Just to remember this, I is equal to V naught. Okay na? You can remember it is to be like this, V naught. Relation between drift velocity and current is V naught. Okay na? So in the next class, means in the next video, we will discuss what is Ohm's law, what is electric resistance, and after that some derivations were there. After that we will solve some problems. Okay na? Thank you.